Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of rotations on the coordinate plane. This is standard 8.10c in the great state of Texas, and we are using item number 30 of the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a triangle here that is rotated, and we need to figure out what is the rule. Now, if you already know the rule for 270-degree clockwise, then it's a really simple problem. For those of us that don't have that memorized, I'm going to see if I can visually represent what that looks like and how we can kind of plot that out. So I'm going to just kind of graph something. I'm going to make it a really simple triangle. It doesn't tell us what type of triangle. So I'm going to make it a right triangle right here. I'm going to make it scalene. I'm going to want it kind of pointing in this direction over here so we can kind of see how it's going to rotate. Okay? And so if we wanted to kind of rotate it, right? If we wanted to rotate it 90 degrees around the origin, you can see it's going to kind of swing down like this, right? And that would be a 90 degrees right there. And then if we swung it around again, right, it would be kind of over here like this. So now this is another 90 degrees, so we're sitting at a total of 180. Then we're going to swing it around together like this. And let's make sure I make it tall enough there. So this is what we're looking for. This 200, it's another 90. So that's going to make 270 altogether. So that's what we're looking for, because if we go around one more time, that's 360, we're back to where we started. Okay, so we're looking for something that kind of looks like this. So if we were to put some points on it, right, let's just make some pretty easy points, right? Let's just make that 1, 1, and let's make that 5, 1, and let's make that 5, 3. All right, so what we're going to do is we're going to kind of run these through some of these transformations and see which of these work. Okay, so let's do this y negative x. Okay, that's going to become our new xy. So we're going to take our originals and let's put those over here. So the originals are going to be 1, 1, 5, 1, and then 5, 3. And so it's going to be y negative x. So 1, negative 1. So I've got 1, negative 1. Okay, that works right there. And then I've got 1, negative 5. Yep, that's going to be right there. And then I'm going to be 3, negative 5. Okay, you know what? This is a 90 degree clockwise turn. So it's good. It's just not what we're looking for. Let's check this next one. Negative x, negative y. That's just going to be kind of looks like it's going to be negative 1, negative 1 right there. So I got negative 5, negative 1. So there's your 180 degree turn right there. And then your negative 5, negative 3 right there. So this is your 180 degree turn, either clockwise or counterclockwise. Let's try this magenta here. If we can get it, there we go. That's going to be negative x, y. And so that is going to be negative 1, 1. Okay, so maybe this one. And then we are going to get negative 5, 1. No, we don't have that. That's going to be like right there. Then negative 5, 3. It's going to be this. Oh, you know what that is? That's a reflection. That's a reflection on the y-axis, not what we're looking for. All right, let's hope it's this last one right here. It's this negative y, x. All right, so negative y, negative 1, 1. That again. Got negative 1, 5. Oops, that's it right there. Now I got my negative 3, 5. Yeah, that's what we're looking for. So there's your 270 degree clockwise, or it's 90 degrees counterclockwise, but that's how we can visually represent it. Our answer is D.